Okay, so I hope you did understand class and objects in the last day's class. So let's delve into Numpy and Pandas. So why use Numpy in the very first place? Because these are all data structures that we have learned. Okay, dictionary lists. Now, in terms of space management, NumPy provides a more efficient storage pattern. Okay, so one reason is NumPy provides efficient. Okay, so and you can handle the data for preprocessing in a better way. Okay, Google has suggested many others as well. It is fast, it is easy to learn. Okay, let's keep that down very way. And it uses less memory to store data. So these are some of the most important aspects that we need to check or we need to consider while working with huge systems. Now, how to import this as in? Okay. So first, let's try creating a NumPy array. Now, what is this int 8? This says that my integer variable will occupy only 8 bits. Okay. So now let's print it, check it. So as you can see that it is of class NumPy array and we have received an array which contains the elements 3, 6, 32 and 7. Next, let's check the data type as well. No, nothing. It is done using the data type. Okay. So now if I change it to 32, it says that it will contain 32 bits. Okay. Also, we can print the shape. What is the shape? The order of the array. So here it will be a 4, which says that I have only 4 elements, not more than that, and it is a single dimensional array. Okay. Now what if I want to convert it to some other dimension? Hmm. Let's see an example. First, let's just declare. Let's keep this for now. So what do you think will be output of this? Any guesses? Any good years with some good guesses? Hello everyone. What will be just in the shape of 4 comma 0? Let's see. I think it will be 1 comma. Hmm. Yes, it should be 1 comma 4. You are considering a single row. Okay. That contains 4 elements. And how is it so? These square brackets represent one row. Now if I just paste another, now you will have 2 comma 4. Clear? Cool. So let's see how can I convert. So first let's see array creation in the type of so do you know what this type of list is called? This is a list of lists. Okay. Where a single list contains multiple lists. Okay. Then we need to typecast it. So did you guys understand what just happened? So basically, if you have a list, okay, and I want to convert that list to some array. So it is very easy. I need to typecast it. So typecast it using what? Using np.array because that is the numpy array format and the rest follows. Okay. Is that clear? I hope it is. What is the data type? The data type this is used to represent that you have considered some string notation that is of 32 bits. Here, if we print my list, what will be the output? We'll just get the list of lists. Okay, so clear. Moving on to the next part is what if you want to create an array that is that contains only zeros. Okay, let's see. We have a function for it. Say np dot zeros, and then you need to enter the shape of it. Mm, 2 comma 5, so 2 rows, each containing 5 columns. Okay, now let's see a what if you want to create a single dimensional array, okay, of say where you want to produce where you want to keep the length to be some n, and you want to have some evenly spaced numbers. So one is being np dot a range. It is just like the range function. If you write 15, you will have an array of 15 elements, each spaced between one. Just like a range does. Now you can write say 2 comma 5 scalar. I don't think this will work. Okay, this produces the tape. Now what if I want to say hmm. Now if you have this 15, okay, you can't directly produce a two-dimensional array of it. So you need to reshape it using a reshape function. But before that, let's cover a few more topics, or maybe we can do it right now. Okay, here print ing, comma, or say keep it shape. Next, I want to reshape it shaped ing equals to ing dot reshape. Okay, they have produced a nice one. So let's consider this. So you have a two-dimensional array, each of so it's the collab notebook of the previous class uploaded in the Google Classroom. The last class that I had taken, I have sent it to THR and she will definitely share it with you. There are dots after zeros in the oh, that is because it is in float type. Hmm. Okay. Hmm. Cool. Now let's learn another function say, what if you want to produce 10 equally spaced numbers within a range? Okay, so I'll keep it 5. I just want 5 numbers. No, I just want it to be within 5. 10 equally spaced numbers between 1 to 5. Okay, so these are pretty much equally spaced near about, and you have this this function for it. And if you want to uh, convert it into some two-dimensional array or some multi-dimensional array, you can always use the rem, reshape function. Sorry. Hmm. Now you can also create empty arrays, but that might contain a few garbage values as well. Okay, so you just need to provide the parameters or the shape of the array you desire, and then it does the job. So as you can see, minus 0.25, minus 0.50. Okay, these are all garbage values. Okay, you can also create an array mimicking some other, like Numpy, print emp. No, I had converted. No, what are the 1, comma 5 and 10 for? Just look at this. I think this pretty much explains itself. 1 to 5 is the range between which you want to pick the numbers from, and 10 means provide me 10 numbers. Okay, Paul, cool. But the question is, okay, I have print emp. I have printed emp. Ah, so now you can see that I have tried to create an empty array that has the same shape as that of L space. Okay, so this has created me an empty array. Often it might contain, so often it might contain a few values of from the same array, or it may not contain any number from that array. Okay, so what I want to say is that often you might have garbage values which may not be these 1, 1.44, 1.88, and sometimes it may mimic the contents of the array you are copying. Okay, so now as you can see in this, L space produces an array of these contents. So here it has copied the same, and sometimes there might have been something else like minus 0.25, 0, 2.0, 95 similarly. And how to know which how these values will be represented? Okay, there is no fixed pattern to know. This depends on various types of compile. Okay, for example, VS Code might result in one thing, pie chart might result in something else. Okay, is that understood? Okay, guys, please give me a time to go because I fumbled in this one. So I would like to know if you have understood it properly. Otherwise, I'll explain that again without fumbling. Okay, cool. So you must mention that if you have not understood. Can you please explain emp.emtr? Okay. So suppose you want to create a temporary array for something. You don't want to fix it values into it, but you want an array of certain size. Okay. So basically you're just trying to declare an array. For that, you will want to declare an empty array. Obviously, don't want to fix it values into it. So this np.empty provides you such an array of that type, of that shape. So 4 comma 6, you have 4 rows and 6 columns. Clear? Now these minus 0.25, minus 0.50, these are garbage values. What do you mean by garbage values? These are system generated values. These are not accurate values. Here the numbers look quite nice. Sometimes it might look very ugly as well. Okay. So done with the EMT part. Now you have an EMT like function. Okay. So as the name suggests, okay. So create an empty array. Like what? Like the array I am asking you to. Here I have asked the device, I have asked the compiler to create an array of the type similar to L space. So this will mimic the order of L space and create an empty array. So often this might result in an array that contains the same values as that of L space. Okay. So as you can see that the values of EMP and L space are same here. But often since it is an empty array, I am creating an empty array. This might result into garbage values. That is, the array elements might be garbage values. And how can you predict if it will be some ugly value or it will contain the value of as it will contain the value same as that of L space? You cannot predict it. Okay, this varies from compiler to compiler. For example, the compiler of VS Code might mimic the same values as that of L space, whereas for if you rerun the code, then the values will change, right? No, this won't change. Okay. For one compiler, this generally keeps the same value, and especially since it is a cloud-based compiler, this will keep the same value. Okay. Hmm. So where I was in VS Code, might result in an array that copies the same value as that of L space, whereas pie chart that might create values that are different. Okay. So I just restarted the session and I'm running all the cells again. So you will see that this keeps the same value. Okay. Even in my previous class of Numpy and Pandas during the ideas summer internship did contain the same value. It did not change. So this actually varies from compiler to compiler. If you use a device that stores values in your local memory, that is in your local machine, then it might result in values that are different. Clear? Okay. Hmm. So now to create an identity matrix, you all know what is an identity matrix, I guess. Nevertheless, an identity matrix is a matrix that contains one as its diagonal elements. and the remaining non off diagonal elements are always 0. Okay, so I think you have understood this. So any doubts till now? The random seed is fixed. Yes, you can say that the random seed is fixed in case of Google Color. If you even if you run it in your device, you might get the end up getting these same values. Clear? Hello. Okay. So in case of NumPy, let's just be aware of the NumPy axis. So for 1D, you have just a single axis, which is the row, that is axis 0. For 2D, you have axis 0, which is denoted by which denotes the row, and you have axis 1, which denotes the column. And of course, a 3D would mean a tensor and so on. Okay, so suppose I have an array with I can keep the comma here. Okay. So suppose I want to print the sum along the rows and along the column. Okay. So the function for it would be sum. If axis equals to 0, then summation of elements on the same rows. If it is on axis equals to 1, then summation of elements along the same columns. Clear? I should this for your better understanding. Summation of 1 plus 4, 7, 5 plus 7, 12. Okay. Okay. So this just produce the sum adding the elements of the same columns. Okay. Axis equals to 0. Okay. So row 0 value added with row 1 value added with row 2 value. Okay. So how, so did you understand that why are we not saying it as summation of elements along the same column instead, because this provided the sum after adding the rows. Understand the notation carefully. Row 0 value added with row 1 value added with row 2 value. Clear? So it is summation of the rows. Okay. So row 0, this is my row 0. This is my row 1, 4, 5, 6, and 7, 1, 0 is row 2. Again, row 0, row 1, row 2. Clear? Now, when I am using ARR dot sum axis equals to 0, so this basically adds my rows. Okay. This is why you are getting 12 plus 8 plus 9. See, row 0 plus row 1. What would you get? 5, 7 and 9. Add it with row 2. What will you get? 12, 8, 9. So this is summation of the rows. Correct? Now, summation of the columns. Column 1, 1, 4, 7. Added to column, column 0, 1, 4, 7. Added to column 1, 2, 5, 1. 3, 9, 8. Added to column 2, 3 plus 3, 6. 6 plus 9, 15. And then 0 plus 8, it is 8. So 658. What? Okay. Is that clear? Do you understand it? Okay. Ariana says that she did not understand. Okay. So Ariana, just focus here. What are my row 0 values? My row 0 values are 1, 2, 3. What are my row 1 values? 4, 5, 6. What are my row 2 values? 7, 1, 0. Okay. So now I want to add row 0 to row 1. Then 1 plus 4 will be the first element, that is 5. Then the second element would be 5 plus 2, 7. And likely the third element will be 6 plus 3, 9. Cool. Similarly, now add this result to row 3, which is my row 2 here. Okay. So 7, 1, 0 added to 5. So 7 plus 5 is 12. 1 plus 1 plus say 7, it is 8. Okay. 6 plus 3, 9 plus 0, it is remains 9. Right. So do you understand it now? Okay, cool. So I hope you will understand the columns part as well. Right. Now what you want to specify just a single element. Say I want to uh, mm, say here are 2, 3. 3 is out of bounds, sorry. My bad. So it should say 0, 2. 0, 1. So it is 2. Okay. Similarly, if I write 1, 1, it is 5. This is the notation. Notation for 2. Okay. Now, what if I want to transpose this matrix? Do you know what is a transpose? It means the rows will become the columns and the column shall become the rows. Cool. Mm, Wrong place. Sorry. Mm. Okay. So as you can see that the column became the row and the rows became columns. So a better view for you guys would be. Okay, is this clear? Okay, for part. Okay, just look at this with the notation 1 comma 1. This basically means this element. Why? Because okay, the first index, this represents the row and this represents the column. Which means, what does this mean? The first column element of row number 1. Which is my row 1? This 4, 5, 6. And which is my first element of row 1? This is 5, right? This is the first column of the second row. So I hope you have understood. So far so good. Are we clear? Yes, clear. Now what if you want to flatten the entire array? Okay, you just want a single dimensional array. So you need to flatten it. What if we want sum of just one row? Okay, I need to think of it. Hmm, sum of just one row to 0, then I think a sum of one row. I think what you mean is sum of one column. Or how can you get sum of just one row? That would just mean 1 comma 2 comma 3. Or do you want to sum all the elements of that row? Sum of all the elements. One is write a proper for loop code for it. Otherwise, if you're asking for a function, I need to look into it. Wait. Got it. Mhm. This should work. Hmm. For the first element, 10. Okay, it worked. Nice. Cool. Okay, so Lakshman, look into the notation. It is the array name followed by the row whose sum you want and then dot sum function. Here, okay. Now you might also want the sum of the corresponding column as well. So let's see if we can do this using single column. But wait, the first column is 2 plus 7, 7, 7 plus 1. Okay, so we are done with this part. Cool. Okay, so going forward, what if we wanted to flatten array? It is very simple. ARR dot flatten. Then okay, the flatten version. Cool. Now you can also traverse through all the elements of this flattened array. It's very simple, like this. Okay. Then there are also other few functions like uh, number of dimensions. Using error.indim. Then you can also check the byte size. Okay. What each element of the array occupies. What byte size is occupied by each element of the array. And obviously the shape. You have this. There is another function called no. Okay, what these suggestions I tell you sometimes they can really irritate or disturb. So this will provide you the byte size occupied by each element of the tag. And if you want to uh, know the total byte size, then for this you have error.n bytes. The error.ravel is another function that will convert it into an array. Okay. Just it just prints it in a list format. How is the shape 3 comma 3? You have three row elements, you have three column elements. That is why it is 3 comma 3. Now I have given the size ARR dot size. Okay, not ARR flat dot size. If you might have mistook it there. So suppose I have another array. What can I name? I don't know. Let's name it 1. Next, we will look into certain functions. Okay, and see what do they actually do. Okay, so if you want to know that which element is of maximum value, then you have a function named 1.argmax. So what does it do? It will return you the index value of the maximum valued element or the element that has the maximum value. Similarly, for finding the minimum value, you will have one the admin function. Now, what does this np.sort do? sorry, sorry for the fun. So, will that produce you the sorted array? No. Rather, it will produce you the indices, which, if placed correctly, shall produce the sorted array. Let's look into it, then it will be more clear. Okay, this did produce the sorted array. Okay, so that is arc sorted. Good. Will produce you the. Uh-huh. Mhm. So you'll get a nice comparison. So you see that if you place the 0th element in the first order, then the fourth, then second, then first, then third, then you will have the sorted array. Okay. So did you understand what I'm trying to say? Or should I explain it once again? Should I explain it once again? Anybody? Okay. So Rashid wants me to explain it once again. Okay. I don't know why I'm fumbling so much today. Okay. So that argmin function. Okay. So the argmin function, this will produce you the index that contains the minimum element in that array. Okay. Next, about the np.argsort. So it will produce you the values of the indices which, if placed in this order, will actually provide you the sorted array. Which means, okay, let's see. So the value of 1 is at index 0, value of 64 index 1, then 4 is index 2, and 634 in index 3, and 2 is index 4. So now, if you see, 0 means 1, 4 means 2, 2 here means 4, 1 here means 64, 3 here means 634. So 04213, if placed in this order, then you will get the sorted array. And I've also printed the sorted array using np.sort. Clear, Rashid? Clear, Amit? Anybody has any type of doubt? You might consider it to be silly, you might consider it to be a very difficult one. Please ask me to explain it once again. Never feel hesitant to ask doubts. Should I proceed or should I explain this again? Sort 1. Why 1? Because the array name is 1. Okay. Okay. So we are done with this single dimension array. Okay. Next, with the double dimensional array, let's just print it once again for our references, and then I will print the mirror.argmin. I'll print mirror.argmax. Now along the rows and columns, this is along the x-axis, this is along the, okay, let's keep it this way, along the, and their equivalent minimum argmin versions. Okay, so I got the matrix via print r, print array, whatever. Next, I want the minimum element. It says position number 8, which is this one. Why? 0, 1, 2, 3. Sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8. Clear? Then I want argmax. It says 6. Why? 0, 1, 2, 3, 4, 5, 6. Clear? Then argmax along the x-axis. It says 2. Why? Why these two? Anybody? 2, then 1, then 1. I want somebody from you guys to explain this. Keep in mind the concept of rows and columns that we had visited using sum. and then respond. I want any one of you to provide a nice and sweet explanation, please. In the chat box. Hmm. Let's see what have you observed till now. Okay, I want you to explain the observations of these four. Okay, let's go one by one. For argmax equals to 0, what does these indices denote? What do these indices denote? Yeah. 1 for 7 for second position. Then for 2, you might consider multiple representations as if for x is equals to for row wise or column wise. Why this? They are indices of index of max elements of each row that I can understand. But how is the row being considered? Okay, Orgoduti, you are right. Yeah. Mm-hmm. No, Orgoduti, you are right. It is row. Even Mahiguha Priya Prakash, you are right. Okay, so let me explain it for the first row. From each row, I want the maximum element from each row. Okay, how? Between row 0, row 1, row 2, which elements have the maximum values. So, for the 0th index, for the 0th index, the second row, or you can say for the, yeah, for the 0th index, the second row, sorry, has the maximum value, which is 7. Next, for the first index, okay, I have the maximum element in the second row, correct? And for the third index, I have maximum row for the second element itself again. Okay, so I have 2, 1, 1. Similarly, argmax along axis equals to 1. Okay, so along the first index, I will check which is being 2 again, then 2 again, then 2 again. How is this 2 to 0? Any good observance? Max row wise. It's like 4 rows now. 367, 367, 367. Okay, cool. So as you can see, arcmax axis equals to 0. Okay, so if you want to see axis equals to 0, keep axis 0 as constant. Okay, that means you will check along this axis, which is along x. So if this represents x comma y, and you know that axis equals to 0, so which is variable? Y. Okay, so you want to fill these elements, you have to fill in the y values. Now for the first y, that is 0 comma 1, you need to fill this. So from these three rows, which has the maximum element? 7. So it is index 2. Next, to fill in 0 comma 1. Okay, which has the maximum element from this? Which has the maximum element? 2. Correct. Next, for the 2, maximum element is 5. That means it is 1. Next, you have 0 comma 2. Okay, you want to fill this space. So again, the second element, it is 1. Now along the x is equal to 1, axis x equals to 1. Sorry, x is equals to 1. Okay, so the first, so the column variable remains same. You need to shift in the row elements. Okay, that is the variable part now. That is the column remains constant and the rows are variable now. Okay, so along the 0th rows, you have to fill in the 0 values. So 1, 2, 3, which has the highest element? Second value, that is 2. Again 4, 5, 6, which has the highest element? Second. And then 7, 1, 0, which has the highest element? That is the 0. So 2, 2, 0. Clear, Lakshman? So if I say x is equals to 0, you keep the 0 as constant and then you search along the ones. Okay, that is here in respect to columns. You can consider it as so. Now, if it is x is equals to 1, then you keep axis 1 as constant and you search along the rows. Okay, clear, Lakshman? Clear, everyone? Similarly for admin. So have I been successful in explaining it to you, or do you want me to explain it to you guys again? Please feel free. Don't be hesitant. You should have your doubts cleared, crystal clear. Okay. Sir, please explain admin and max. Okay. From the very first point, admin means the element that will have the minimum element in the minimum value in the matrix. So if you consider this position as 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. Okay, so the minimum element in this entire matrix is 0, which is located at position 8. Then you say arcmax. The maximum element is at position 6, which is 7. Now arcmax axis equals to 0. Okay, so you keep the axis constant and you check in this pattern along the rows 1, 2, 3, 1, 2, 3, 1, 2, 3 in this pattern. Okay, so 0, 1, 2, 0, 1, 2, 0, 1, 2 in this pattern. So what will you do? Since axis x is equal to 0. 0 is constant. So you will check along these columns. Okay. So within 147, which has the highest value? 7. So 2. Within 251, which has the highest value? 5. So it is 1. Within 6. Within the column 360, which has the highest element? So 6. Now along axis equals to 1. So the column is fixed and you have to search within these rows wise in each row. So in row number 1, which one is the highest element? 3. So it is at position 2. Where is 6? The highest element in row 2, and 7 is the highest element in row 3. Okay. So you have 2 to 0. Clear, Ashaf? Okay. So let's proceed. So similarly, you have arc sort for this also. You can try that out. Not going into that. Now, what if I want to copy this array? It is very simple using dot copy. Okay. Let me create another array. Numpy dot array. Mhm. Okay. So these are my two arrays. Next, we look into certain matrix operations of NumPy array. So the typical addition here AR1 plus AR2, then you can multiply them. So these operation AR1 star AR2, this means this is a Hadamard product. What is that? What is this fancy term Hadamard product? Basically, in place multiplications. Okay. So if I execute it, okay. So 1 star 1, 1, 2 star 2, 4, 3 star 1, it is 3, 4 star 4 is 16, 0 star 5 is 0, 6 star 6 is 36, 8 into 7, 56, 1 into 1, 1, 0 into 0, 0. Clear? You can also call it element wise multiplication. Yeah. Scalar addition, multiplication, division, and subtraction. Now, if you want the mathematical multiplication, then you can say which one? No, 40 element wise multiplication. It is called Hadamard product. And for matrix multiplication, it is very simple. There one, there two. Hadamard, Haddamard. Okay, so this is your matrix multiplication. Tool that is called or element wise multiplication. You can also call it element wise multiplication. Hmm. So you can also print a few things based on certain conditions. Basically dot product. This is basically dot product. So you are here you might get division error. So divide by 0. Okay. So you also have this AR1 greater than 5, which will basically produce the indices that have elements containing values greater than 5. Okay. You can also count the number of non-zero elements. So you have 8 non-zero elements in AR1. And you can also print the non-zero elements in each array as this. So this will produce you the positions. Okay. Okay. So let's proceed into Pandas. Please show above code once. Wait, check this. So let's get into Pandas. Okay. So as always, Pandas are obviously very beautiful. So these pandas is also very cute, just like the original pandas. There was a professor in my university who used to prove graph theory problems and then used to claim this is a very cute proof. And we used to say, how can this be so cute? Because they were very dangerous proofs. Okay. So for pandas, we need to create certain data frames. What are data frames? Basically your data set in some usable format for you. Okay. So there's one way of creating a data frame, that is, let me just produce a dictionary and then convert it into a data frame. So here I have numpy only used for matrix operations. Yes. Mostly for linear algebraic techniques, you need the numpy. Okay, so I have created a dictionary. Now I want to convert it into some data frame. Okay. Now let me print the data frame. Hmm. Okay, so you have a beautiful data set type structure or a table type structure for further operations. Okay, now we need to convert it into some data set format. Okay, with this .csv, the most popular, one of the most popularly used versions. So can be like this. Now we can also read it via okay, using the read CSV function. So within CSV's comma separated values, it is a Excel like extension. It is a file extension where basically you can consider that a base or some data set is stored in terms of tables, that is rows and columns. Okay, it just looks similarly, or you can say similar to a Excel sheet. Clear? Okay. So for each CSV, then there might be a NaN value or some missing value. For example, suppose let's not write this. Mhm. Okay. So since this is a dictionary, it is not considering that. So okay. If I try to write it, I'll get an error because in a dictionary, it is always that the number of elements in each section must be the same. But even if you have missing values in your data frames, then that is usually represented as capital N O N E, or it is NaN, basically not a number. Okay, clear. Now you can use this my CSV. Suppose you want to print the name column. Here you have all the names. Now, what if you want to see the marks of the second person? Mm, You can also change it. Now, for the data frame part as well, you can operate similarly. Okay. My CSV, when loaded from this, is basically a data frame as well. Okay. This is equivalent to DFA. Clear? So when I use pd.read CSV, it automatically converts an Excel sheet. Here you can say a CSV sheet into a Pandas data frame. Clear? So if you use this function, it will by default produce you the first five elements of the list. Here you have five, so I can also print two. Then I will have only two records or two rows. You can also print the last two using the tail function. What is this? Oh, sorry. Okay. So the fourth and third. Can we download this CSV file into our PC? I don't think you can download this CSV file because it is generated in the cloud. Let's see if it has. No, the folder structure. Yeah, you have this, so you can like just download it on the download option. Yeah. Hmm. Sample data. I don't know what is in this sample data. We have some other CSV files as well. You can try these. Okay. You can also add indices to it using my CSV dot index is equal to, but this is quite mechanical. So I would suggest you can skip this thing. You will also get something known as unnamed. So I think this is more of a unwanted hassle. Okay. So I would always suggest you to skip this. Then you have something known as the series function. So what will this do? You have series are equals to ed dot series mp dot ran mp dot random dot ran 34. So then yes, yeah, okay. So can anybody predict what this will do? Just a random guess, a wild guess. Don't Google it or something. Hmm. 1D, we can understand 1D. Now what will this do? I have used a few other functions as well, right? 1D version of a data frame. Oh, not really. Random ways from 0 to 4, 0 to 34. What do you mean by random ways? Okay, let's see. Random series. Correct, correct. So you will have randomly created numbers, 34 numbers into a array. Okay. This Panda series is basically, it is an array. Okay. So you get a 1D array where you have 34 numbers. As you can see, these values change as well. So let's focus on the first number, 0. Okay. So it did change. Cool. Now, if you want a data frame using random creation, say new df is equal to data frame, pd dot data frame. Next I say np dot random dot rand before. What will this do? This will create a 334 rows, 5 columns table. And by this I have just produced the indexing of the array. Okay. So this basically controls the indexing, and this creates 334 into 5 values based in 334 5 data frame structure order. Rather. Cool. Now, obviously you can check its head and tail. This function, what does this do? You have a describe function that will like provide you the count of each value, 0 1 2 3 4, the number of elements in each column, mean of each column, standard deviation, mean value of each column, first quartile, second quartile, third quartile. They show above code. This one. Now you can also convert it into some numpy array using the two numpy functions. Okay, so you get an array. You can also sort based on index, like new df dot sort, sorry, underscore index. Which numbers? These. These are randomly generated system numbers. There's no specific range for it. So this was sorting along the axis equals to 0, which is along the x-axis. Now you can sort along the y-axis as well. I mean, these are float. Can we do it for int also? Yes, you can do it for int also. You need to see there's might be some tweak in the function, and then you can do it for integer as well. You need to see. Well, I think it's just some basic modification. After comma, you write something, just int or int 8, whatever. Okay, cool. And all the data frame functions that we had seen earlier work in this case as well. Then you can copy data frames from one to another. New df2 equals to new df dot copy. You can also change few values if you would like say I want to change 0 comma 0th value to say 9.765. Now print df2. Okay, 0 comma 0th has changed. And similarly change something else 0 comma 4 3. Why didn't it change? Okay, Mitra. So the third 0th column of the third row has changed. This is the notation. Next, next what do we have? Okay, we have this location function. No, the notation seems unlike so. In fact, even I had thought that it would be the third column that would have changed, but I think they are using the second or the third row. Sometimes these change their policies and things change. 0.6, okay, it did not change. Hmm. So you also need to restart your kernel at times. Otherwise, as you can see that it had previously changed. So if you want to change the 0 comma 4 like this, you should use the LOC function or the location function. Okay. So clearly in this case our interpretation was wrong. In this case, the third row that has the 0th index, 0th column gets changed. However, oh, I think what it does is this basically denotes the column name. Yeah, for a data frame within brackets, you write the column name and then you were selecting which index you wanted, right? Even previously, when we had done this, I think we had checked the column name first. See, so first is the column name in this case, and then from this column, which element do we want? So similarly, this is followed in this case as well, where first I check the column name and then I see which element from that column I want. Okay, clear? Everyone clear? So I can also change the column names using Okay. So I have replaced the names of the columns. Now let's see if this works like what we wanted. Hmm. Okay. So the desired value has changed. Similarly, I can also use LOC as say I want to change 0, comma E. These both of these work. New df head dot to it produces the first two rows from the data frame. Clear, Shorodipta? Now what if we want to drop a column? This will basically delete one column from the data frame. Okay. Why doesn't this work? I did have an E column. Yes. So why is it not recognizing this? What if I write 4? Hmm. Where the 2? Where the 2? Oh, okay. Sorry. I was using new df here. I thought I was using new df2. But it still shows head E. Why? This should not happen. This should not happen. Okay, maybe restarting this might work. Restart and run session. No, it still does the same. But why is this so? Does drop work on head? No, head is for printing or for showing the by default the first 5 rows. Okay. In other case, you can also use other number to print some other number of rows. Say if I do 10, it will produce the first 10 rows. Okay. But my question is, and this does work. This is a standard function, and why is it not working? There's nothing wrong with the syntax, nothing wrong with anything, in fact. Then why doesn't this work? This is my only question. What if x is equals to 0? This shouldn't recognize x is equals to 0. E found not found in axis. Okay. Let's see if it deletes a row. No, this is an absolute shocker because this is a completely standard function. And if this does not work, I don't know what should work. Let's see, let's see. Maybe in third brackets, that is, want to write. But let me check the syntax. Better to search for the syntax instead of randomly. Implicit equals to true. Let's see. Please help me on guys here. Because I have used this previously and I really don't know why this does not work. So have they changed some syntactic lingo? Okay. Thank you, Aditya. Thank you, Aditya. Thank you so much. That's fine. So it just worked now. And now it shows some crazy error again. Is there some problem with the kernel? It is already dropped. Yeah, it did drop. And then there is a crazy error when I rerun the kernel. Okay, it works again. Completely fine. Now let me just switch it to 2. And something crazy happens. And this does not work. I switch it back to 10. It still doesn't work. Now I restart session and run all. And this will work. So what is this? The column is already... No, but it is not saved, right? It is not saved anywhere. So if I try to operate it after this line, then it should happen. Does memory hold the drop thing? No, memory does not hold the drop thing. Exactly. But now it does not work. The memory does not hold this because it follows a hierarchical order. So maybe it considers that I am... Okay, so if I execute this... Okay, I think it considers that I am executing this and then... Okay, I think it considers that I am executing this. It stores it in the memory and then when I rerun it, it thinks that I am duplicating this here. It thinks that I am duplicating it like this here. Nice observation. Hmm. Okay, so finally we did find the solution to our issue. Hmm. Okay, so I also checked in that when we write in plus equals to true, previously I think it used to consider by default that in place was true. Now it considers by default in place is false. So when I write false, it already deletes it. So if that is the issue, then let me drop column B. Let me check if it is false. Hmm. So my column B is not false. So previously they used to consider it as in place equals to true. And now they consider it as in place equals to false. Okay. So now if I change it to true, it is dropped. Okay, nice. Now if you want to mm, print specific values from the data frame, so if you want to print the first and second row from column P and column. Hmm. So this is the syntax. And if you want to print all the rows from P, oh, in place means that whatever change happens, it will occur in the original space of the positions in the table. Good. Hmm. Okay. So if I use the colon option, if I don't write anything here, then I just get all the columns from C and D. You can also print values from your node.ref dot loc. Okay. So if you just specify certain conditions, for example, from the column A, I want only values that are less than 0.3, and from the column C, I want only values that are greater than 0.1. Okay. So I can get it in this method. This is my logical AND operation. You can also write AND, that should work as well. Okay, AND does not work in case of these techniques. Okay, so we'll use the ampersand sign. This is my logical AND. Mhm. So it works completely fine. Yeah. You can also Say, suppose you have already deleted some rows and you want to reset the index from the original part. So you can also use the index. But sometimes Impress also means that it will produce a new object instead of just providing a copy of what was stored. Okay. So previously it was some, I did not delete any row, right? No. Let's try deleting a row. Say I don't know since when Google Colab started facing so many issues. They considers new TFS the Avengers one. I wrote TF. Oh, sorry. Thank you. Okay. So as you can see, using this zero, the zeroth row is deleted, and now when I have the data frame, it starts from one. Okay. Now when I use this reset index, this one that becomes row zero. But why is it showing something else? Okay. Here, this first row becomes the zero. So do you guys have any doubts? Okay. So using this drop function, I have deleted the zeroth row from the data frame, and the new data frame, the resulting data frame starts from 1. Okay, that is row number 1. Now, what if I do some operation? I want my entire data set to be considered from 0 again. Okay, so I need to reset the indices. I do that using the dot reset index function. Clear? So this thing starts from, yeah, the zeroth row. The first row becomes the zeroth row. Cool. Do you guys have any other doubts? No, so everything is clear. Whatever we have learned till now. Anybody, any doubts? So the drop equals to in reset index drops the index value. Yes, correct. Yeah. Okay, so with this we come to an end of the Python classes. You will have to bear my classes once again when I'll teach you regression and classification. Till then, mm, it's a good